She has contributed to vehicle theft detection using sensors and voice-controlled robot developed at ECIL. She has presented her research at international conferences and has published papers in reputed journals, including IEEE. Her research interests lie in IoT, embedded systems, VLSI devices, and artificial intelligence. Today, she will be sharing her insights on sensor, actuators, and intelligent D communications, a crucial topic in the evolving landscape of smart systems and intelligent communication networks. Let's extend a warm virtual welcome to Ms. Khushi M. Ashudharia as she shares her valuable insights with us today.
Thank you, madam. So I welcome you all to the session 3 of the ATAL FDP, which is on sensors, actuators, and device-to-device communication. The agenda for today's session is, first we will be looking at the introduction of IoT in healthcare, and then we move forward to basics of sensors and actuators. Further, we will move to the main part of device-to-device communications, and furthermore, we move to the applications in healthcare. Finally, we will see the future scope of integrating the sensors, actuators, and day-to-day communications in healthcare. And finally, we move to conclusion. After the conclusion, we hope to have a hands-on session with the participants. So coming to the first, today we will explore the crucial roles of sensors and actuators and device-to-device communication in healthcare. So these technologies are for transforming how we monitor, diagnose, and treat patients. So over here in our agenda, we are going to cover a personalized healthcare and telemedicine and Internet of Medical Things. The objective of this FDP as well as today's session is to understand the basics of sensors and actuators. So like I was telling, we were here talking about the basics of sensors and actuators. So the basic science of sensing and actuating is the process of transduction. So transduction is the process of energy conversion from one form to another. So a transducer is the physical means of enabling transduction. So like we said, transduction is whenever we convert an energy from one form to another form, right? So the forms can be an electrical, mechanical, chemical, or light and sound. And similarly, we can again convert it to another form. Like suppose it's an electrical signal is the input, then we convert it to a mechanical signal, or we might convert it to a chemical or a light or a sound, such type of signal. Okay, so this process is called as the transduction. Moving to the next part. So coming to the basics of sensors and actuators, let us see how a transducer performs. So to the transducer, I give an input signal. Usually we give the input signal to a sensor. Why? Because a sensor converts a physical signal into an electrical signal. Hence sensors are used at the transducer input. Now an input signal which passes through the sensor comes out as an electrical signal or an electrical impulse. This electrical impulse can be sent to the processor for further processing or based on whatever logic we are applying, right? And after from the processor, once the logic is coming, we will be then sending it forward. That is again an electrical signal which comes out of the processor, and that is given as an input to the transducer output. So at the transducer output, you can check over here is the actuator. So what does the actuator do? The actuator takes in the electrical signal and gives out the output signal, which can be again the physical signal. Okay, so let us see with an example how a transducer works. So over here, suppose I have a sensor. The sensor is to measure the moisture of the soil. Okay, so the input of the sensor is what? Moisture, that is water, which is a physical thing. So the physical signal goes into the sensor, and what will be the output of the sensor? It will be an electrical signal, which will be the data which shows the amount of moisture in the soil, right? Now, based on that, I will write in the processor a certain logic. Let us suppose I write the logic as a threshold value I will give. That suppose the moisture detection is up to 50, then I want to turn on the sprinkler. And if it is less than 50, I want to turn on the sprinkler. If it is more than 50, no need to turn on the sprinkler. So that is the process which I have written in the logic. So the sensor will give the input as what will be the input? Can anybody tell? So the input will be the signal, right? The amount of moisture. So suppose I got now from the sensor, I got the value as 80. So now from 80, what will happen? It will come to the processor. What is the logic in the processor? That if it is above 50, I don't need to turn on the sprinkler. If it is below 50, I need to turn on the sprinkler. Now my sensor give the input as what? 80. So since it gave input as 80, what will the processor logic give to the actuator? That don't turn on. What is my actuator over here? My actuator is the sprinkler, right? So what is a sprinkler? It will take in the electrical signal and give output as the physical signal. So currently what it is, my actuator, that is my sprinkler, is turned off. Okay, right? So this is how the process of transduction takes place. Now let us see in detail what is a sensor. So the sensor is that detects the physical, chemical or environmental changes and convert them into electrical signals for processing, right? Here in the diagram, we are looking at a sensor node. That is, a sensor node or a sensor device should have a following 4 components. One is the sensing unit, which is at the left side. If you observe, the light, temperature, force, position, speed, pressure and chemical, right? So that are what the sensors, different type of sensors which form the sensing unit. Now each of the sensing unit, what does it do? It gives the electrical impulse to the processor, right? Now other part is what? Other part looks at the communication unit. What does the communication unit look like? So the sensor might send the data over the communication network. That is what is IoT, right? Okay, so what are the different communication unit processing we are using? Wi-Fi, Bluetooth, Zigbee, right? RFID, Z-Wave, ZSM. So multiple such communication units are available for us. Okay, and apart from that, what is the next input do we have? We have the the power unit. Why? Because it is not always compulsory that whatever is my input, it should be a digital or it should be an analog input, right? So for that case, we will be having a power unit also. Over here, actuator is kept as optional because most of the times it is not compulsory that whatever my sensor senses, it should at the end of the process have an output or a reaction. Okay, sometimes I just want to sense and monitor the data. Like for CCTV surveillance, I just want to monitor the data. Okay, I don't want to perform any output. Okay, maybe I will have a physical output for that, not an actuator to be used. Okay, right? Next, moving to the next part, we are talking about the sensor characteristics. So all sensors, whenever we go in the market, we want to buy a sensor, we should make sure that the sensor which we buy should not be very sensitive and should not be very rugged also. Okay, so what do we make sure that there are few characteristics which are very, very important, which we need to keep in our mind when we look at the sensor characteristics. Okay, so let us move into them. The first one is the sensor resolution. What is resolution? Which is the smallest change in a measurable quantity that a sensor will detect. Okay, even a small change, especially where the sensor resolution we see in our real time is in our cameras nowadays, right? All our mobile phones, because now all mobile phones have all the features. So what do they show in the advertisement? Camera, 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 mana camera manchi, like that, right? So the sensor resolution is what? It is able to capture even the smallest change in the measurable quantity. Okay, nowadays we also have what? Our cameras are integrated with AI. Why they are integrated with AI? To detect the smallest change and to enhance whatever is the outlook of the picture. Okay, right? So higher the resolution of your sensor, the more precise is your measurement. Okay, but we should not confuse accuracy with resolution. Okay, okay, accuracy is another characteristic and resolution is another characteristic. Okay, sometimes yes, it is possible that a good resolution will provide a higher accuracy, but not always. Okay, so we can see an example given over here that there is a temperature sensor. So our temperature sensor which is detecting up to 0.5 degree change in the temperature, and there is another sensor B which is detecting 0.25 degree change in temperature. So now it is concluding that resolution of B is higher than resolution of A. Why? Why? Because A is what? 0.5, whereas B is detecting half of that, even half of that 0.25 change also it is able to detect it. Okay. So here you can see I have taken an image. Now this image over here, you can see it is divided into so many rows and columns, where each row and column is called as a pixel. So the same picture is over here. A bull's eye is taken, and for the same bull's eye, you can see that there are two. One high resolution image. Why this left side is high resolution? Why? Because let us take this first, in the first box, let us take the third row and third column. Okay, third row, third column, I will select this one. So in that, what happens? See, the small change of this bullseye circle is also it is capturing. Whereas if I look at the right hand picture with the low resolution, if you observe, it is capturing more data. So there is a higher chance, because of large amount of data being captured in a single pixel, that there will be what? Blurring of the image. Okay, right? So it will have a lesser clarity when there is a low resolution. So the higher the resolution, it is the best. Next, moving to the accuracy. Like I said, resolution and accuracy don't mean the same. So looking at the sensor accuracy, what is accuracy? Ability of the sensor to measure the environment as close to the true measure as possible. Let us explain with the example. Look at the diagram over here. Now over here within the circle, if someone hits right at the center, that is the ideal value. Okay. But now what is happening? Whatever the person is hitting, it is not coming close to the ideal value. So the blue dot is the measured value. So it is closer to the ideal value, but it is not very far and it is not exact also. So we will call that as a good accuracy device. Whereas look at the right cornermost one, what it is showing, the blue dot is right at the corner. So it is a very poor accuracy. Why? Because so much, it is so far away from the ideal value. Are you able to get this point? Okay, so that is called as the sensor accuracy. So there is, now I hope you understood the difference between a good resolution and a good accuracy. Okay, right. Let us move to the next one, precision. Precision is what? Precision indicates that even multiple times, if I am calculating the same value, I should get the same result. Consider, for example, I am going on a diet. Let us take that as an example. Okay, I am going on a diet. Currently, I weigh 80 kgs. Okay, first day of I am going to follow my diet strictly. Okay, let us believe that, even though I won't, but let us believe that I'm going to I'm going to follow my diet very strictly every day. First day, I will measure my weight. What will I expect? A certain decrease in my weight. Next day, I will expect a more decrease in my weight, but what is happening? It is showing my weight increased. How much was my weight? 70. Next day, it showed 68. With the same diet, next day, it is showing 66. So, usually, dietitians will tell that, Madam, thode pehle ke din to first few days aisa fluctuation hota. Now, let us think that after 15 days also, this fluctuation is happening in my weight. So, now what will I tell? I will tell, because it is a human nature. What will I say? The device weighing machine is not good, right? We will tell like that, weighing machine is not good, my to diet follow, I am following my diet, right? Okay, so that is the same example over here. So let us see the example at the downside, that is the high accuracy and the high precision. So can you see where I want to hit? I want to hit at the center of the bull's eye, and the blue crosses indicate how many times I'm going to hit. So each time I'm hitting exactly on the bull's eye, so it means what? I am a very good archer, high accuracy and high precision. Whereas look at someone who is a novice, right? So I have to hit at the bullseye, but where am I hitting? I am hitting far away from the bullseye. So it is what? Low accuracy, but high precision. Why? Because every time I'm hitting there only, maybe some problem in my eyes. So I'm going on hitting on that side, but it is what? A high precision, but low accuracy. So I'm not going to win the Olympics, right? And next we are going to move to the third one, that is a high accuracy. Why? Because every point, if you see, I have hit it close to the bullseye. So I'm going to gain the points, but it is not exactly hitting the bullseye. Every time just to miss. Just to miss means I'm going to get what? Bronze medal now. Right? So it is a high accuracy and a low precision. Coming to the last point, if you see, it is like, let me tell that when we started practicing archery. Okay, so neither we are hitting the bullseye nor we are hitting at the same place every time. So it is a low accuracy and a low precision. Okay. So that was regarding the sensor characteristics. So the three main sensor characteristics, let us go back: resolution, accuracy, precision. Next, moving to sensorial deviations. Why? Because over a certain time, we place the sensors in the natural environment. So there is wind, there is dust, there is sun, right? And there is a wear and tear. Why? Because it is an electronic device. Somehow or the other, it will get a wear and a tear. So due to that, I will get erratic outputs. So when I start getting erratic outputs, I need to understand why that error I am getting. So in order to understand that, I have to go for sensorial deviations calculation. Okay, so over here, when we are taking applications like healthcare and industrial monitoring, so over there, I cannot say that today I got heart attack, tomorrow I will not get, or today in the evening I got. No, it will sound so stupid if I'm a doctor and I will tell, no, this deviation, no, nothing will happen. No. So it does not work like that. Okay, so when we are having a healthcare type of sensitive application, we need to make sure our sensor is very precise. Okay, so first of all, in order to make my sensor precise, I need to calculate what is the deviation happening. Okay, so here I am giving a few of the famous deviations, I should say, which we need to see, which we need to check when we are not getting the correct output for our desired inputs. Okay, so first one we are seeing is the drift. What is drift? Yeah, if anybody young like me in the audience, then we know Tokyo drift. Right, it is also the drifting of the car. Okay, apart from that, let us see the technicality of drift, that if the output of the signal of a sensor is changing slowly and independently of the measured property, that is called as a drift. Okay, the output of the sensor changing slowly and independently means on its own. Nobody is providing an external interface or an external interference. At that time, it is called as the drift. Where do we usually see this? In noise, right? When we many times, once the signal is coming, I can hear somebody very properly. Next time, what will happen? I cannot hear the person and I can hear background noise more. That is called as the noise. Okay, so the deviations of the random deviations of any signal is called as the drift. Okay, next coming to the offset error and bias. What is offset error or bias, right? So whenever I teach this to my class, I tell that this is the favorite word of the students, that is bias. Madam to bias. Madam to bias, but that is not true. Okay, so I don't show that bias, but students feel it. Okay, so what happens over here? If the output of the sensor is differing from the actual value, output of the sensor is differing from the actual value which need to be measured. So for example, I want to tell that the temperature is what? 0 degrees. Okay, but it is showing as 1.1 degree. Every time I'm measuring, it is showing 1.1 degree. So what will I say? We call that as a bias. In that device, 1.1 is the bias. So what will I do? Next time when I'm calculating, suppose I show 2 degrees. So what I'll do? 2 minus 1.1, that is my actual value. Okay, let us move forward to sensitivity error. What is sensitivity error? Sensitivity error means, see, whenever any device we are having, especially a sensor, so it will have an operating range. Okay, it will work within that operating range. Okay, so that operating range where we have a fixed maximum and a fixed minimum value, that is called as the sensitivity error. Sensitivity error in the sense what? See, we will say no, plus minus, right? Plus minus, that is called as a sensitivity error. So suppose I will tell that the current room temperature is 35 degrees. Maybe in another sensor it will show as 35.1. So plus minus of some value, some sensitivity which we will use, okay, which goes out of the range, that is why it is called as the sensitivity error. Okay, so whenever we are finding that, you should make sure that if your device is having sensitivity error, you don't use it in applications like healthcare. Okay, you can use it in applications which will be able to tolerate that plus minus limit, right? Now next we move to the hysteresis error. What is hysteresis error means? Hysteresis error is for the same quantity at the same time at the same input, I will get two different values. I will repeat it. For the same quantity with the same input, okay, at the same time, I will get two different values. How I'm getting that two different values means, observe over here. What I'm doing, once I'm increasing and once I'm decreasing. Okay, once I'm increasing the force, once I'm decreasing the force, due to which I got a certain loop like this. Now at this particular dotted line point, what is happening? A hysteresis error is happening. What is the hysteresis error? What is the hysteresis error? At the same point, at the same time, at the same applied force, what is happening? I'm getting two different values. So the difference between that values is the hysteresis error. Okay, I hope no doubts. If you have any doubts, you can post it in the chat. Coming to quantization error. Quantization error is very important. Why? See, all these errors keeping in mind of healthcare. Why? Because such errors will definitely occur in sensors on healthcare devices or any other sensor also. So what is quantization sensor means? Let us look at the diagram. Actual value is this, what this step thing. Okay, this dotted line is the actual value. Okay, and now what I'm doing, I am creating a digital approximation. Whenever I'm going for an analog to digital type of conversions, these quantization errors will come. Okay, so you can see that I'm converting a straight line into few steps. Okay, so here the difference you can see where it is showing the quantization error. I'm not sure whether you can see my pointer, but in case you're able to see, it is written as quantization error. So this small difference which is happening between the digital value and the original signal becomes your quantization error. Okay, it is also called as rounding error, where suppose over here what is the value? The value is 100.5, but I'm rounding it off to 100. Okay, I'm rounding it off to 100. So that is called as quantization error, where I'm rounding off. Okay, usually we do, no, usually students ask us to faculty, madam आधा round okay full होता क्या? That's the part. Okay, next, moving to analog to digital conversion, right? So like I explained in the quantization error, whenever the difference between the actual analog signal and the nearest digital approximation will take place, that is called as the analog to digital conversion, and the error which will occur in this is called as the quantization error. Moving to the next one is the aliasing error. Aliasing error happens whenever there is a mishandling of frequencies. Let us look at one of the frequency diagram which we have taken over here. Okay, so I have provided the fixed sampling rate, and now what is happening? There is a signal. Okay, there is a signal over here. Let us look at the left side. Can anybody tell me the one where there is a dotted, like it looks like a noise over there? Does it belong to 0 or does it belong to minus fs? To which part does it belong? Can anybody tell? Okay, right. So we cannot tell to which part this particular signal belong to, whether it belong to minus fs or whether it belong to 0. Okay, so due to this, what is happening? Whatever data is present in between of this, due to this overlapping, whatever data is present, what will happen? It will convert into noise. And suppose I'm running a machine learning model, then what will happen? It will just omit it off as a noise. Okay, so what if there is some valuable data over there, it is lost. Okay, so that is called as your aliasing or mishandling of sampling frequencies. Okay, right. So that was regarding the errors. Just a quick feedback or a quick recap. So the sensorial deviations are drift, bias, sensitivity error, hysteresis error, quantization error, ADC error, aliasing error. Next, moving on to sensor considerations. So what is meaning of sensor consideration? So when I go in the market and I'm a new person, I want to buy a particular sensor for my particular application. So what are the things I should keep in mind? So based on what I want the application to be, I will think that suppose I want to do ECG, I want to perform an ECG. Then what I will do? I will buy a sensor with that particular application, right? I will check in the available market, there will be so many sensors which will perform ECG. What I will do, I will look at the features and then I will see their considerations and then I will buy the sensor. Okay, they're also depending on application. If I want it to be a remote access, so I have to see the range up to which the sensor, from how far away also I can capture the data of the sensor. Okay, so just excuse me. So sensor considerations are what? They are the sensing range, accuracy, precision, energy, and device size. So what is the range? Already we have seen this. The range is what? The minimum to the maximum value, okay, which a sensor can detect. okay, up to a certain range, like we have the Bluetooth. Okay, so what does the Bluetooth do? It will have a range up to from here till maybe to the next room, or maybe one more room after that, and then the connection is automatically lost. So if I want a device which will work only in that range, I want to keep a very constrained type of environment, and I want to keep the sensor to work only in this much area, then what I will do, I will take Bluetooth as my communication module. Okay, right. Next, accuracy and precision. Just now we have seen accuracy and precision. So these are provided by the sensor. Okay, so we can check them. We can check whether the accuracy. We already saw what was accuracy, how much we are close to the measured value, close to the ideal value. And what is precision? Even when I repeatedly calculate the same quantity, I should get the same answer. Okay, right. Next, energy. What is energy? See, I cannot buy, now suppose I have a sensor. I cannot buy a sensor which is costing lakhs of amount of money, and but it is not even working properly, or not even desired outputs it is giving. Okay, it is consuming a lot of energy also. Okay, it is stopping all my hardware, it is taking the most power. I need to give extra power supply in order for that sensor to work. Then such a sensor should not be considered. Okay, why? Because it maintenance also becomes costly. Then deployment, why? Because nowadays IoT is what to make things smaller and smaller and smaller. We want a smart watch. I will not wear a smart watch which looks like this. Will I wear it? No, I will not wear that smartwatch. Right? Why? Because device size is very big. Okay, it will take a lot of energy. I don't want a smartwatch which I need to charge every hour. Okay, nobody will buy it. Right? Coming similarly to the next one, that is the device size. What do we mean by device size? The larger is the size, the more energy it will consume, the more costlier it will become. And what will happen? More people will not want to buy it. Right? A washing machine should be size of a washing machine. Right? I will not buy a washing machine if it is the size of a entire room. Right? Nobody is going to buy it. Okay, especially now when we are coming to wearable sensors. We have seen now the smart watches are there, AirPods, earbuds, all this, right? Wearable sensors. So we want to make the size smaller and smaller. And we should not forget that when we are making the device small, it should not make the energy efficiency low. Okay, energy efficiency should be maintained. Right. Coming to the next part, types of sensors. There are innumerable number of sensors in the environment. What we are seeing are few sensors which will be useful in most of the projects. So after this, we'll also see sensors which are useful in our healthcare. Okay. So first one is alcohol sensor. We already know by the name, we can understand it will detect the alcohol content of a person. Okay, how much alcohol the person has consumed. We must have seen during the Christmas or New Year party, we have heard news that the police people will check the alcohol screening. Okay, right? So that entire thing contains this small sensor inside, which will display, I will blow into the sensor over here, and this output pins will give the digital value of how much alcohol content is there. Next is the ultrasonic sensor. So the ultrasonic sensor is a sensor which is used for distance measurement. So suppose an object comes in front of the ultrasonic sensor, it will automatically measure the distance using ultrasonic waves. So it continuously sends out ultrasonic waves, and whenever an object comes, it will automatically calculate the distance from itself to the object. So where do we use this? Is in your rovers, robots, or wherever you have the object detection. Okay, right? Next is the IR optical sensor. IR optical sensor is using similar to ultrasonic sensor, but it uses what? Infrared waves. Okay, it uses infrared waves. Next is the LDR. LDR sensor is used very widely even in real time nowadays. So it is a light dependent resistor. This is used for automated street lights. Okay, so whenever a light falls on the resistor, whenever light falls on this particular sensor, it increases the resistance value and the LED turns off. Okay, and whenever the less light falls on the sensor, the resistance also decreases and the light turns on. Okay, so that is how the automatic street lights we see on the roads. Next is the gas sensor. The gas sensor is very famous. MQ5 sensor we are showing over here in the picture. So it is used for detecting harmful gases. Okay, whether it is in the coal mine or in a cylinder filling area, okay, or in your homes, we can make use of the gas sensor. Next is the gyroscope sensor. Gyroscope sensor is for calculating your movement, right? If I make a particular gesture, in order to detect that gesture, I will go for the gyroscope sensor. Next is the rain sensor. It detects amount of rain in a particular area. We see, right? Hyderabad received 46 mm of rainfall. Khambam received this much mm of rainfall. Okay, so that is done by this rain sensor, where the amount of rain falling on it, it will convert it into a certain digital value. Nobody is going to stand in the rain and measure, right? How much mm. Okay, next is the sense hat. The sense hat is a board which has multiple sensors embedded on it, which can be used for projects. Next is the photodiode. The photodiode is also a light sensitive device. Okay, it also depends on the amount of light falling on it. It will measure the amount of light falling and give out the digital value. Next is the proximity sensor. The proximity sensor is for calculating the closeness of one object to another object. Okay, so this is the IR proximity sensor, and this is another type of proximity sensor which is not making use of IR. Okay, last one is a PIR sensor. The PIR sensor is very famously used for calculating any type of theft. Okay, usually we see that any intruder detection, that is shown in the PIR sensor. Okay, next types of sensors in healthcare. So we see the biometric sensors. So they measure the physiological parameters such as the heart rate, blood pressure, and body temperature. Here we can see in the middle, we are seeing the pulse oximeter. Within this, on the left side, you can see the sensor which is present, which calculates the SpO2. We keep our finger in this, and then our finger we place it in the oximeter, and it calculates the SpO2 value. At the right side, you can see the ECG sensor. I think in the next session, we will be seeing a live demo of this. So the ECG sensor, we can see it measures the electrocardiogram. It measures the heart rate. Another type of sensors are the invasive sensors. Invasive sensors are used in surgeries, okay, for real-time monitoring. One example which I'm showing over here is the catheter-based sensor. So over here you see that there is a catheter which is going from the mouth into the intestine or into the colon, and then it is want to check the histamine levels. So this particular sensor is able to detect the histamine levels, and you can see that on the screen I can automatically monitor the histamine level of the person. Next, wearable sensors. They are used to track the patient movement, posture, and activity. So over here, most famous ones are the accelerometer and the gyroscope. Difference in them is accelerometer will go for the linear axis, whereas gyroscope goes for the 3D measurements. Next is the environmental sensor. Environmental sensors are, example I've given here as the thermistor and the gas sensor, which will measure the air quality and certain type of humidity, temperature, such type of environmental factors, and give out the digital values. Okay. Next, coming to actuators. What are actuators? Actuators, like I told previously, they will take an electrical signal as the input and convert it into a physical action. Okay, right? Into a physical action. So over here, they've taken a factory automation. So from my computer, I gave a certain signal that start the conveyor belt. So what will happen? The sensor will immediately receive the signal, and what will happen? It will process and start the motor of the conveyor belt. Okay. Similarly, we are seeing here many type of actuators. Okay, usually actuators are motors. Okay, like our fans, motors, DC motors, brushless DC motors, stepper motor, gear motor. Depending on the type of action we want to perform, sprinklers, relays, solenoid valves, switches, push buttons, these all come under your actuators. So a few of the mechanical actuators, thermal actuators, fluidic actuators, these are used in our healthcare. Mechanical actuators, where do we use? They are used for your body or medical equipment like robotic surgery systems. Over there we'll make for mechanical actuators. Next we have the thermal actuators, where we want to control the temperature. Okay, so there are few treatments which make use of cryotherapy or hyperthermia, right? They want to freeze the cells, like your cancer cells, you want to freeze them. So in such a condition, you want to make use of the thermal actuators. Next is the fluidic actuators. Fluidic actuators are what You can see over here insulin pumps. Nowadays we have seen, right? We just keep an insulin patch. Diabetic people, they don't need to keep on getting the injection. That insulin patch automatically it will insert the amount of glucose. It will measure and insert the insulin. Okay, right? So that is a fluidic actuator. Apart from that, also you might have seen in ICUs, right? They will keep an insulin pump. They will keep the measured quantity inside of the drug which is to be administered, and you will see that automatically it will push itself. The nurse does not come and push into the saline or whatever. Okay. Next is the electromagnetic actuators. So these are used in devices like pacemakers. Pacemakers, we all know they are used for heart patients. Okay. Coming to the third most important part of the agenda is the device-to-device communication. What is device-to-device communication? It enables direct exchange of data between the devices without the need of a central or intermediary server. Okay, so it enables the direct exchange of data between the devices without the need of a central system. Okay, how it is used in the healthcare? So it will allow the medical devices, that is the sensors and actuators, to work together and give a real-time monitoring of the patient. And when that real-time monitoring happens, the data is forwarded to the doctor, and then the doctor will automatically, even remotely, he can tell what type of treatment can go forward. Okay, so it is very important in telemedicine. Telemedicine is nothing but your remote monitoring the patient. Okay. Is not moving to the next slide. So just a second, I will reshare the screen. I think we have covered all this. So relevance to healthcare is it allows the medical devices, sensors, and actuators to collaborate, enabling a seamless real-time environment and monitoring. So here we are showing the few protocols and technologies which are used in healthcare. So over here we are using low energy Bluetooth devices. Where do we use them? In wearable devices like fitness trackers, ECG sensors. Other protocols are the Wi-Fi when we want to perform high bandwidth communication, Zigbee for low power communication like a home healthcare, and then we have 5G where we want to use the high speed, low latency communication for large healthcare networks. And then we have NFCs. NFCs are short range communication for data transfer within a medical setup. I want to transfer data from one device into another device. Okay, am I audible? Okay. Next, let us look at, coming to the end, let us see the challenges which occur in the device to device communication. The major challenge comes in the interoperability. Interoperability means what? Right now, I just told, right, one device should seamlessly send the data to another device. So we need to work that different manufacturers who are manufacturing different devices, they should also be able to send or receive the data. Next is what? Security. Why? Because in healthcare, data privacy is very important. We need to protect the sensitive health data of the patient. Finally, the power consumption. So if I'm using a wearable device, I should make sure that it will at least last the entire day or 2 days or 3 days or a week. It should not have a repeated recharge. I don't need to charge it again and again. Okay. Next, we will see the applications in healthcare. So major application like we are seeing is the real-time patient monitoring. So through the wearable devices, we can integrate it over the web or over a mobile app. I can keep a track of the patient. I will just ask him to wear the device and add me or the doctor as the person who will be continuously monitoring whatever is the fluctuations happening or any vital signs which are happening through the wearable device. Okay, right? So especially where there is a chronic conditions like diabetes and asthma, where we need to continuously monitor the patient, where the person, like suppose it's a family member who has asthma. So what I want to do, suppose somebody suddenly got asthma attack and he fell down. So immediately it should send an alert to the caretaker. Okay, right? Next to telemedicine. Telemedicine is what? Remote consultations. Like doctors cannot be everywhere over the world. So even in a remote village, what I will do, I'll just keep an IoT setup. I might need only one person over there, and from there I will be sending the data for remote consultations and diagnosis with real-time data sharing. Just a second. So smart medical devices, that is the next application where we have the smart inhalers, right? Automated drug delivery system. Just now I explained regarding the insulin pumps, right? Then robotic surgery systems where the surgeons use robotic arms controlled by actuators and are used for with along with diagnostic sensors to perform a surgery. Okay. Next, other future scope. Let us look at the future scope of the healthcare using sensors and actuators. So, personalized medicine. Personalized medicine means what? See, everybody does not have the same threshold level or the same allergies or whatever we can tell, right? So, we need to integrate a sensor and data to tailor to the treatments based on the biometric data. Maybe I will capture the skin, or I might take a little bit of the fingerprints, or I might capture the tongue, right? Tongue is also a very useful tool in detection of diabetes and lot of other diseases. Okay, so I might just take the image of the tongue and I will process it and try to know what type of, I might try to take a machine learning model which will integrate into it and give out the output that these are the possibilities for this type of tongue geometry, feature and size. Okay. Next, another scope is AI integration, that is machine learning algorithms which will interpret the data from the sensors. So, see, doctors also, what happens sometimes patients do not follow the medicines which they are giving. The doctor will ask to take the medicine, but we might not follow it. Okay, due to which what will happen, our output might not be as desired. Okay, so then we need to again go to the doctor and he needs to again check the diagnostics and everything, and then he will again give a new treatment. So in place of the doctor doing all that, we can integrate it a machine learning algorithm. Through the sensors, it will adjust the treatment automatically. So these are all the future scope or future projects we can tell. Next is the smart hospitals. So hospitals which are fully integrated with Internet of Medical Things, where the sensors will monitor the patient continuously. Okay, so they are line of patients which is looked after by one single or two nurses at most. So what happens? The patient needs to be continuously monitored. Now every time the nurse might not be able to give attention to only a single patient, right? So what will happen? Suppose there is any abnormality, automatically the nurse will get the alert that at this particular ward, this particular patient bed number, the person needs an immediate attention. Okay, like that. And then that same alert might also go to the doctor, and the doctor will make sure that immediately over the phone also he can just give the instructions to the nurse by the time that he comes to the patient. Okay. So let us see the few key takeaways from the session. So sensors and actuators enable real-time personalized healthcare. Okay, right? So device to device communication is very much necessary, right, for synchronization. It should not be one device is unable to talk to another device. Then it is not an IoT. Okay, right? Then the future of healthcare lies in the integration of these technologies, which will ensure the better patient outcome and a good experience of the patient. It will not overburden the family of the patient. It will not overburden the doctors also. Okay. So I will conclude my session over here. Let me just stop the screen sharing. If there are any queries, you can please post it in the chat. Okay, I am seeing a question in the chat by Dr. Kunal Raval. So, ma'am, any example of interoperability in a healthcare setup? Right, like I said, interoperability in healthcare setup. That was only my last example which I was giving. That both the devices. See, suppose I have a patient. See, multiple organ failure patients. How do they occur? Okay, I'll tell from my personal experience. Okay, so multiple organ failure patients. What happens in them? First, maybe the kidney does not work, maybe the person already has a prehistory of diabetes. Okay, with they have not monitored their diabetes very easily. So what happens, the patient, he is feeling proper and well, he's thinking I am fine, I am good, but in the end what is happening, it is falling a pressure on maybe their kidney or their eyes or some another organ. Okay, so what happens, the interoperability over here comes where when the devices which are present, they should, now suppose I'm integrating IoT over here, means i I will want to, so there is no such device currently available, but I will want researchers like myself as well as few PhDs which I see in the chat, and people obviously all are interested in IoT. So you all, I will make sure that someday we will have a device which will be small, compact, and it will sense. We just need to make it like a wearable device, a very small device, which the patient will not feel that I am wearing such a heavy thing on me. Okay, and he'll be able to see, monitor their entire health. Okay, so interoperability in healthcare setup is, that is what, multiple devices working together. Okay, to monitor the patient. So I should immediately know when the diabetes patient sugar goes high, immediately the insulin pump should take care. Okay, sometimes what happens, over insulin also leads to creatine effects on the kidney. Okay, so I should even monitor the kidney of the patient. Okay, so these two things have to work together. I also need to monitor the eyes of the patient, because they will lose eyesight, such type of patients who have no control over their diabetes. Okay, right? So I hope I answered your question somehow, Dr. Kunal sir. Okay, yeah. Where can I get data sets, madam? Where we always get our data sets, madam? Kaggle, or you have to take a real-time form, or you can go to government hospitals and you might take a notification from your MROs to for them to access patient data. Usually they don't give unless it is signed by a higher authority. I have tried it with one of my students, the project, to get a data set from the government hospital. Right, we were seeing about breast cancer detection. So it was a little bit difficult, but the student was having a bit of influence. That looks so cheesy to say, right? It's usually the student expects the faculty to give out the inputs, but yeah. So the data sets are, you will get them online, ma'am. You will find the data sets online. If you don't find them online, we have to take the help of our health service providers. So Dr. Medicoda Asha Kiran, ma'am. I hope I answered your question. Seemingly a little bit of off, but yeah, that is where we find our data sets. One new message, where can I, in agriculture, farm plant disease, which sensor is used? In agriculture, farm plant disease, right? So actually, this is a very integrated topic. Okay, it does not only work with a sensor. You have to integrate your machine learning models to capture the images and then run a model behind in order to see which type of disease you are going to detect. Apart from that, we can see in farm remote monitoring we can do, and remote monitoring and control we can do mostly for agriculture. That is, we can check for the moisture levels, we can check for the NPK values within the soil. So they are sensors which are available for uh, calculating the amount of potassium, nitrogen present within the soil. Okay, so if the, so based on that we can also control the amount of fertilizers which are falling. We can control the pesticide usage, right? And with the sprinklers we can make sure that the entire field gets evenly it gets the water. Apart from that, I can also keep a weather monitoring sensor in order to predict which type of weather will be, which type of season, and which type of crop I should keep. So for the diseases, usually we make use of the advanced machine learning models where we capture a particular plant through the IoT. We can make a rover. The rover captures the image of the through the farm, and it might capture all the images. Once the images are captured, what happens is we can send that image process through the rover directly to my computer, where a machine learning model will run behind, detect the type of diseases, and then I can send the same rover to pull out the weeds or pull out those plants which are affected with the particular disease. I hope I could answer your question, Mr. Manohar Undi, sir. Okay, thank you for the session. Thank you all for listening and making it so interactive. For the hands-on session, today we will be just seeing basic things. Okay, we will be seeing regarding our session, that is sensors and actuators. So I will be doing the simulation. Why I am going for simulation is that I want participants also to be doing along with me, so that they will feel that it is a real-time hands-on. Okay, apart from that, of course, we will also be showing hardware. We will place the hardware over here and try to also show in that way. Right, any other questions, or we can move for a short break? We'll be starting the session in a while for hands-on. I request all of you to sign into Walkwe using your Google account, wokwi.in. I request all of you to please just sign in and let us at least do a small thing so that we can feel that we learned something from the sessions. Before moving into the session, we will go to Akshaya ma'am's question, that she wants to do research on emotion detection using sensor data. So which sensors can I use? So ma'am, more than emotion detection, nowadays feasible is your gesture detection, but emotion detection requires a bit costlier type of sensors like the EEG, ECGs, and the radar sensors, RGB cameras, okay, infrared sensors, okay. So, and such type of facial recognition analysis. So you will mostly, if you want to do it in a very cheap way, then I will suggest you that you go for a camera and run a machine learning model behind, right, in order to go for the emotion detection. So we also have the sentiment analysis part, right? So if you want to integrate completely IoT, then it is a bit of a costly, but yes, it is possible. We have the EEGs. EEGs are electroencephalography, I think, and they will measure the brain activities. Then we have the ECGs, which will measure the heart. We have seen in the films, right? We will use the ECGs as a lie detector test. Okay, so that is like the emotion detection. So if you're feeling sad or happy or that, we can see it. Okay. So Akshay ma'am, I hope I answered your question. You can directly message or you can put it in the chat. Are we all ready for signing in into Walkme? Shall we start with a hands-on session? Okay, right. Uh, I will start it anyhow. I can see a lot of participants. So I hope all of you have signed in into Walkme using your Google account. I'm sharing my screen. Is my screen visible? Right. So currently I'm keeping my video off because I'll be looking more into the laptop. I won't be able to keep a proper connect with you all. So I hope you can just follow my instructions or words and we can move forward. So I hope all of you have logged in and you can see a similar screen in front of you, right? So this is a simulator, a very advanced simulator actually. There are other simulators also available, like if I have Tinkercad and similarly. I have chosen here Walkway, okay, because it has multiple interfaces. You can see on the left side, it works with ESP32, STM32, Arduino, Pico, and blank. Okay, so I am going to go to Arduino, and we are all, please follow me. Click on Arduino and click on Arduino Uno. So you can see it is showing it as the beginner friendly. So we'll just click on that. right? And you can see that there is an Arduino board over here. Before moving to the Arduino board, let us just see a few points regarding the Arduino board, right? So few important points. I will not go into too much into the details. Why? Because it's just a hands-on and I don't have much time. What we'll require is the digital pins 0 to 13. So if there is any digital device, digital sensor or actuator that we are connecting, then we connect it to the digital pins. Then downside we have the analog pins. If I want to connect any analog type of sensors, okay, like the LDR, right? We spoke about the LDR. The LDR is the analog sensor, and then the LEDs are the digital devices, or sprinklers are also digital, wherever you have only two things on and off. Okay, and then there is the power pins over here. You can see power is written. So over there we give the power supply 3.3 volts, 5 volts, ground, and so on. Okay, so for those who are new, so Arduino is used for interfacing external components. It is a microcontroller. It is made by Atmega 328P. Okay, Atmega 328P is the manufacturer of Arduino Uno. So similarly, lot of boards are available like this. You can see, right? There are multiple Arduino boards. I'm using Uno as it is beginner friendly. The first hands-on session that we are going to do is a very simple experiment where we are going to connect an actuator. So the actuator is the LED over here. So Arduino, if you see the circle over here at the left side, it is written as L near the negative sign of Arduino, right? So it is called as the built-in LED. The built-in LED is internally connected to pin number 13 of your Arduino device. Okay, right? So we are just going to write a code in order to turn on this LED and then turn off the LED. Looking to the left side, whenever, see, for Arduino, we also have in real time the Arduino IDE, but currently we'll be doing the simulation part. So if you install the Arduino IDE, you will get to where the basic structure of the sketch is the void setup, where we write the code to run once. Usually all initializations of the program we will do under void setup. Okay, and then we have the void loop. The void loop is where we write the logic of the code. Okay, whatever we want to run repeatedly. Since it's a microcontroller, what happens is once the device is the code is uploaded, right, this arrow mark over here indicates that the uploading of the code. Once the code is uploaded, what happens is it will run forever within the controller unless you overwrite with a new program. Okay, so over here we are going to use a built-in LED. Pin number 13 is also built-in LED. You can see the code over here. What I will do is I want you all to just copy the code into the IDE, right? So what I will do is I'll share the code in the chat, not make you all work a lot. Okay, so I will share it. Okay, your screen sharing. Where does the chat go? Chat and control V. Okay, so I'm sending the code. I want all of you to copy paste the code into the. I want you all to copy paste the code into the walkway. Okay, right? Just control V and you get your code over here. Okay, I hope all of you are following me and you are doing along with me, right? It's just somebody can unmute and tell, or I can go a bit more slow. Are you all along with me? Okay, so this particular code, we are seeing that we want to initialize the chat. Okay, so yeah, we want to initialize the pin. So I'm connecting to pin number 13. Pin number 13 will automatically blink this L. Can you see this L over here? This LED is built-in LED, which is connected to pin number 13, right? And then I'm introducing what? It is a LED. LED is a digital device, hence I will use the function called as digital write. The digital write function, what I'm doing, I'm turning on the LED. So I've written as high, then I'm waiting for a second, then I'm turning off the LED and again waiting for a second. So whatever I write in the void loop will go on continuously. Okay. Right. So now what I will do is once the code is done, you can just simply start the simulation. There is no need of any external things. Build somewhere. Okay. Right. So just run it again. Okay, it's showing the build servers are currently very heavy. I am getting such an error. But maybe once all of us after the meeting, we can just check it out. You just click on the simulation, and what happens is the LED turns on and turns off. Okay, yeah, you can see the LED turning on off every second. Okay, so this is how we interface an actuator. So if the actuator is a digital device, I will make use of the digital write in order to overwrite into the digital device. Okay, so here there is an LED. Apart from that, I can also make use of a LED also, no such issues. Okay, right. So I hope everybody's LEDs are blinking on the simulation. Okay, right. So we'll just stop the simulation. So that is one of the thing. And moving to the next we want to interface. I will not go for LED and switch. Why? Because it is again two actuators. LED is also an actuator output device, and the push button is also an output device. What I will do is I will go for a sensor. I will go for a sensor over here. Like I explained the LDR, so I will go for the LDR sensor. What I want all of you to do is go to the walkme, stop the simulation, click on the add button and search for LDR. Search LDR. Okay, not LDR. We will search for photoregister maybe. Is again showing LDR. Yeah, just click on LDR and you will get a LDR sensor like this. Right, go to plus, search for LDR and just drag and drop it. You just need to click, no need to drag and drop also, just click, you will get the LDR. So you can see over here, the LDR is present. Okay, the LDR is present. There is a potentiometer to adjust the sensitivity. There is a VCC ground, device data and A0. Data out and A0. Okay, so before moving to the connections, what I will do is first I will share the code. I will share the code over here in the chat. Right. I'm just overwriting it because already I have a lot of things. So those who don't want to override, you can just go back to the dashboard and click on a new project. Okay, you can just click on a new project and you'll be able to see you have to again make the connections. So I will keep it in the chat. Right. You can copy paste from the chat. Are you all done? Let me know when you are done. Just copy paste the code, search for the LDR, connect it. And those who are a little bit forward, you can just connect as per VCC to the VCC in the power pin. Right, you can go for the 3.3 volts, ground to ground in the power. We are not seeing the data out A0 in the code. Where are we connecting A0? The LDR, right? So we are going to connect A0 to A0 of the analog sensor. Okay, right? We have to do only that much. No need to connect D0. I'll repeat again, connect VCC. Just drag and drop the wire. Right, so it's automatically showing the areas where we can connect. So I'm going to connect it to 3.3 volts. And then we have the ground. I will just take a wire. You just need to single click. Single click. Again a single click to change the direction. It's highlighting the grounds which are present on the Arduino. I can connect to any one of the ground pin. No need to connect to D0. Next, I'm going for the A0. So the A0 I'm connecting to A0. Right. So A0, why I'm connecting A0? Because I gave in the code as A0. If you look at the left side, I gave in the code as A0. You can use any other analog pin. You can use A0 to A5, any one of them. Right? Now, what do we want? What does the LDR work? How does the LDR work? That wherever the resistance increases, the LED should turn on or off. Right? So whenever the resistance increases, I want the LED to be off, the built-in LED to be off. And whenever the resistance decreases, I want the LED to turn on. Okay. So are you all with me? So once the connections are done, you can just run the simulation.
Ma'am, kindly share this connection numbers in the
It
chat.
is taking a bit of time. I don't know why. For such small projects, it should not take, but it is taking some time. Okay, I'll just build again. All of you, please make the connections how I'm telling. I have kept a threshold of 500. So because in the logic I'm giving that if the LDR value is above 500, then I want the LED to turn on, else it should turn off. Okay. Yeah. So getting 250, right? So what I was telling is when you will go for the simulation, currently I'm unable to build. I'm getting a server error. For those who are able to compile, just click on the LDR. You will get a slider. So with the slider, what you are supposed to do is you can just increase or decrease the brightness. Okay, you can increase or decrease the brightness, and based on that, you will see the LED turn on and off. So here what we are doing is we are integrating both a sensor as well as an actuator. The sensor is the LDR and the actuator is the LED, right? Did anybody get it? I'll try once again to compile. I hope the code is understandable, self-explanatory also. Again, I got error. Right. Anyhow, so I'll just explain the code quickly. So first I'm giving a integer for LDR A0. Then I'm giving an integer for LED 13. I'm creating a variable threshold. I'm giving it as 500. Then I'm setting up the LED as the output. Next serial dot begin 9600. So serial dot begin is for printing the values, right? You can once the simulation starts over here, you at the bottom you will get the values of the LDR. So you can read the LDR values. How that is possible is you should always make use of serial dot begin. Okay. So serial dot begin initializes your serial monitor to the Arduino Uno. Right. Next, I'm calculating the LDR from the LDR pin, that is A0. I am getting what the analog read. Why? Because LDR is an analog device. Since light is an analog signal, the light value is falling on the LDR device. I'm getting the LDR value. If the LDR value is greater than the threshold, what I want the light to turn on, else I want the light to turn off. So I'm just going to print the LDR value. Did anybody get? Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. Okay, sure. You all became experts like me. Ha. Okay. So I will just stop here. We have our session finished. We will have another hands-on session later on. So the remaining parts are just an LCD interface and all those things. And we have a small, simple dice game simulation where we will make use of a push button and LCD. Right? Okay. So I will stop share my screen and we might get ready for the next session.
Thank you, Ms. Khushi, for your insightful session on sensors, actuators, and intelligent data-to-data communications. Your expertise and research contributions have provided us with a deeper understanding of how these critical technologies are. We truly appreciate your time and effort in sharing your knowledge with us today. Now, moving on to our next session, it is my pleasure to introduce our second speaker for the evening, Mr. K. Anil Kumar. He is currently working as an assistant professor in Department of Computer Science and Engineering, Data Science at KMIT Hyderabad. With an impressive 5 years of industry experience working with IoT devices, microprocessors, programmable logic. Thank you, Ms. Khushi, for your insightful session on sensors, actuators, and intelligent data-to-data communications. Your expertise and research contributions has provided us with a deeper understanding of critical technologies. We truly appreciate your time and effort in sharing your knowledge with us today. Now, moving on to our next session, it is my pleasure to introduce our second speaker for the evening, Mr. K. Anil Kumar. He is currently working as an assistant professor in Department of Computer Science and Engineering, Data Science at KMIT Hyderabad. with an impressive 5 years of industry experience working with IoT devices, microprocessor, and programmable logic devices, along with 14 years of teaching experience. Mr. Anil Kumar brings a wealth of knowledge to the field. He is actively contributed to research, publishing papers in reputed international journals, and have successfully undertaken several projects in diverse domains. His academic excellence is further reflected in his achievements as an NPTEL topper in IoT, Python for data science, and microprocessors. His research interests lie in IoT, artificial intelligence, and cloud computing, making his expertise highly relevant in today's technology driven landscape. Today, he will be speaking on applications of IoT and medical devices, a topic of great significance in the era of smart healthcare solutions. His insights into how IoT is transforming the medical field will surely be valuable for all of us. We are honored to have him with us today. Let's extend a warm virtual welcome to Mr. K. Anil Kumar as he takes us through his session.
Good evening, all. Thank you, Riddhi ma'am, for the introduction. My topic is application of IoT and medical devices. Let us see the contents first. So I start with the introduction of IoT. I will not take most time on introduction. No? Just I want to give an introduction of IoT in my own healthcare point of view. Then let us see how IoT works in healthcare. Then we'll see IoT in medical devices, how the IoT works in medical devices, and what components we require for IoT medical device. Then what benefits we have for IoT in medical devices. Then we'll see some applications of IoT enabled medical devices. Then we'll see how to implement IoT in medical devices. And what challenges we have to face while implementing the IoT in medical devices. At the end, we'll go with the case study with the hands-on session. Let us start with the definition first. So I'm not saying it is a new one for you. You have been listening to IoT definition in the last sessions also, but I want to explain the different way in view of healthcare. Yeah, this is a definition of IoT. IoT is a dynamic global network. Why I'm calling dynamic? Because it has to change its behavior or it has to react according to the situation. And why I'm calling global? Because it has to work in the worldwide. Infrastructure with self-configuring capabilities. Why I'm calling self-configuring? Because I'll give a simple example. In my home, I want to on a TV which has a Alexa inbuilt or have a Android device. When I turn on the device, it automatically detects my Wi-Fi network. That is called self-configuring. So manually, we are not doing anything again and again. I'll give one more example. If you take any latest laptop, if I connect a pen drive, in olden days, we need to install again the device drivers to detect the pen drive also. Whereas now, it is when I connect a pen drive, it already detects the pen drive, right? It is called self-configuring. We are not configuring again and again now. In IoT also, the devices should configure and detect the devices. This is called, they have to communicate also. That is called interoperable communication. Interoperable communication. I'll give example now. Suppose you are crossing a signal and you jump the red signal now from a junction 1 now. The IoT is such a way that if it has interoperable communication, it automatically communicate to the other next junction without human intervention that this vehicle number has crossed the red signal and they are able to catch you in the next signal. This is called interoperable communication. In a healthcare also, the different devices, a device which is taking the scanning of a brain and the device which is taking the scan of a heart should communicate. This is called interoperable communication, where the physical and virtual things. Why I'm calling physical? Because in healthcare, the human being which we are there or individuals what we are physical devices, and they will be assigned some virtual identities. So physical and virtual things have unique identities. Why the uniqueness is important in IoT? Because let us take example. If you are an engineering student, your rule number is a unique. It will work for anywhere you go out of the world. You go to the world. Your rule number is unique. Similarly, for IoT device, the unique identity should be there. Example, the IP address or URL or URM. So these are unique identities from where we can communicate with the other devices. It can be a IoT device or any other device, but while communicating in the IoT network, we should have a unique identity. Now, what thing can be? The thing in IoT can be any device. So I'm saying it's any device or object, including human being. Why I'm saying? Because our motto is to discuss about today healthcare. Even a human being or a patient, technically is a patient that has been assigned a unique identity. Suppose that 100 patients in the hospital, every patient should have a unique identity and as ability to transfer and collect data over the network. The sensors connected to the patient has to communicate and transfer data and collect data over the network, which will be monitored by the healthcare professionals from a remote place. Let us come to the starting basic one. Today's market, there are more than twice as many connected IoT devices as there are people in the worldwide. So the sentence says that the IoT devices are more than the human beings of population in the world now. Let us take example of myself, of my home only. I am using a smartphone. I'm using smart earbuds, and I'm using a smartwatch. I'm using a laptop. In my home, I have a personal PC. For me only, there are 5 IoT devices. For me only, there are 5 IoT devices. In my family, the other family members are also using similar kind of things. So in a family itself, even in my families of 4 people, we are using more than 10 devices connected to the IoT. I may use fridge, I may use AC, I may use a washing machine, a TV, which all can be connected to the internet. Now you get a doubt, sir, our population is huge. All may not use the smartwatch. All may not use the smartphone. Now how they calculate is, let us give you example. Let us see what they're giving is. In 2024, the United Nations published a new world population. There are 8.2 million human beings on planet this year, and the projection of in 2050 will be 9.7 billion. At present, in 2024, as per the data taken, it is 8.2 billion human beings are there. Our population is 8.2 billion. Now coming to IoT devices, a latest study says we have 18.8 billion connected devices in the IoT. So 8.2 is the human population, 18.8 billion is the IoT devices. Now some people may get doubt now, sir, there may be a villages, we don't have the mobile access also. How they calculate is number of people available in the or living in the world and number of IoT devices available in the connected to the internet. It is not individual case. Number of people living in the world to the number of devices connected to the internet. So in this way, there are more than twice as many connected IoT devices are there than the people in the world. There will be over 40 billion IoT devices within the next 5 years. If I go to the 2050, it is showing 9050. If I go to 9.5 billion people will be there, but in next few years itself, it will be 40 billion IoT devices because of the availability of cloud and big data, and IoT devices can be able to communicate through the cloud. Now coming to the revenue, how much they are spending, how much they are spending in the IoT. Worldwide IoT spending has been increased over a year by at least $40 billion since 2018. In 2020, IoT spending reached around $749 billion. In 2022, the global IoT spending was increased, predicted to be 1 trillion. This was a graph taken by 2 years back. Now, in 2023, retail spending rose of is around 1.1 trillion. So day by day, the amount spending on IoT is increasing because there are advantages or the facilities available from the IoT is very useful to us. You can able to monitor the patient come remotely. You can able to control the cars or devices from remotely. You can able to turn on my AC in the home remotely. So companies are spending lots of money on the IoT to make the things more lavish and more accurate and more remote controlled. Let us see how IoT works in healthcare. IoT for healthcare works by connecting various devices and systems that are used in hospitals and healthcare to network. So we are concentrating only on the healthcare department now. So the devices are variables, can be a ECG, can be a thermometer, it can be a SpO2 device or sensors, medical devices or electronic health records like ECG. These IoT health devices have capacity to collect and transmit data in real time. This is very important to respond in time for the patient. So IoT health device has a capacity to collect data, and today we are going to see a live example of collecting and transmitting data in real time to the health professionals in a hospital or a clinic. So we are today in case study, we are going to see a ECG of a patient who is there here can be transmitted to the hospital or a doctor in a remote place where he can monitor from remotely. This is a big advantage of IoT in healthcare. So the advantage is we will get accurate and up-to-date information about the patient's health. We'll get a minute-to-minute data of the patient. It's generally used when the patient is in a serious issue or an ICU case. Now, there is an effective and simple process in which IoT in healthcare provides valuable information. For that, I divide this complete communication into 4 blocks: data collection, data analysis, communication, decision making. So we'll see one by one step here now. First, we'll go with the data collection first. You can see here, first we'll collect data, then we analyze data, then the data is transferred or communicated or sent to the health professionals through IoT, then the decisions are taken by the healthcare professionals. Let us see first with data collection. Collecting data, what we require? We require through a various sensors. Data collected through various sensors like DS22 or MLS904 of SpO2 and LM35 for temperature, and so many are there. There are so many various sensors which can sense the temperature, various parameters or vitals of the patient. And these devices constantly send data to the remote place. The data collected may include patient's vitals such as heart rate, blood pressure, respiratory rate. It may also include information about patient's activity levels, how he is active or is not having the not well, or he's not active, he's not doing any patterns, or he's doing actions or not. We'll call in tele, and we'll ask to perform some actions where we can analyze him, and we'll see some sleep patterns, how he's behaving while he's in the sleep mode, or when we give a anesthesia, how he performs, how he behaves. Then data analysis. After collection of data, we'll analyze data. So one data is collected, it is analyzed using various algorithms and machine learning techniques. So for analyzed data, the data analyzed can be done in machine learning algorithms through the cloud sending. We can send data through the cloud platform. This is possible because of different cloud computing platforms like Fimbase. Now, after this, communicating or data transmission. After analyzing data, we should send the data to the other end, where the healthcare professional, the remote doctor is there. The patient is in the hospital now, and you want to communicate or send data to the healthcare professional. The data collected and analyzed is transmitted in real time to healthcare professionals. They can visualize such information in smartphones or tablets or PCs. There will be a dashboard or app where they can monitor the patient vitals and they can give some suggestions. After the data transmission, we'll see the decision making now. For data transmission, we have multiple platforms. Then we'll go for decision making now. One data collected, healthcare professionals can get clear picture on the patient's health status, even though he's not there with the patient. Because of the collected data is transmitted over the cloud through IoT, the professional can get clear picture of the patient status, health status, allowing them to make or informed decisions about their care. They may change the medicine. They may say increase the dose, or they may say take one more scanning. So this all can be possible because I is able to analyze the data remotely. After analyzing data, a doctor can take decisions because he has a clear picture of the status of the patient, even though patient is not with him. For instance, a IoT medical device shows a patient heart rate is constantly high. Suppose, example taken, a patient is there in the home or a hospital where the doctor is not available, where his heart rate, his BP is high. Now, healthcare providers may alert to the potential problem. Then that will give alert system also that he is having some problem, because in hospital there will be 10-20 beds. Every second the caretaker will not be there at the patient. In such cases, the device gives alert also at the source side as well as to the remote side also, where he can be alert and do the necessary actions. Then IoT in medical devices. Let us see what is a medical device. IoT enabled medical device offers healthcare providers the ability to monitor patient remotely. Now I'm coming to directly to the medical device. Then what we require for a medical device, we'll see. And make data-driven decisions. What do you mean data-driven decisions? So as data is available for the doctor remotely, he can take decisions on the data available to the doctor and improves overall care of the patient. Here, data-driven means as data is available to the healthcare professional remotely, he can take decisions based on data given by the IoT and cloud platform. This technology shift is fundamental, changing how healthcare services are delivered, making care more efficient, personalized, and accessible. Now, as the health professionals are able to monitor the patient remotely, it is more efficient and what is personalized. If we are able to monitor the patient continuously, he may suggest some personalized scannings or medicines for a particular patient, and he can able to access it because he is able to accessible. He may give some instruction to the caretaker to do some necessary actions to improve his health. Now, what components are required for IoT medical device? As our previous session, Kushima discussed, this will be basic components of any IoT device or any IoT device. It can be medical device or any device. The first one is sensor. These devices measures various health metrics. I am concentrating only on the health metric here, but the sensor, general sensors is an input device which sends the physical or a physical phenomena if it is an analog device, or a digital data if it's a digital sensor. Sensor is the input device which can analyze, we can sense the physical or analog data. So in our applications, as we are concentrating or at health metrics such as body temperature, oxygen levels, blood pressure, glucose levels, sensors act as a data source for IoT device. Without sensors, even though a patient is available, if sensors are not there, it is not possible to monitor him remotely. Sensor plays a crucial role for monitoring the patient vitals. So sensors are very important. While choosing sensors, it is our responsibility to take proper sensors to monitor the required parameters. Then actuators. Actuators are responsible for taking action based on sensor data. For example, if patient heart rate exceeds a threshold, a actuator might alert healthcare providers or activate emergency protocols. So actuators are output devices. As there is an emergency from the sensor sensing data, the actuators will take action now based on the sensor data. Here example given is a patient heart rate exceeding the threshold. The actuator might alert the healthcare now. He may provide an alarm system, or it may say a buzzer alarm. It is an actuator now, which will activate emergency to the caretaker or who is there available in the ICU. So sensor is the input device which is going to, I'm saying only about an healthcare perspective of view. Sensor is a device which will read the vital of a patient, and this data is exceeding, the vitals are exceeding the threshold point. Suppose my BP is now 200 or my temperature is 104 degrees centigrade. In such cases, this actuator will give a alert to the providers or caretakers such that they will take the immediate action to reduce the loss. Connectivity, these are very important. So even the actuator is there, sensor is there, without connectivity, it is not possible to monitor remotely within the hospital, also within the premises of the hospital, or without beyond the hospital. If it is beyond, we'll use this basic connectivity devices with a cloud. But within the hospital, if you want to be somewhere in the other floor, you want to monitor the data, then we have require just a Bluetooth or a Wi-Fi or a 5G or Zigbee. If it is a remote place, along with this, we require a cloud platform. Then we require cloud computing. That's nothing but IoT data analysis. For computing means the whatever data provided by the IoT device will be analyzed in using a cloud computing. So the IoT device rely on cloud storage, securely store and process data. So here the data is securely sent to the healthcare professional. This data is accessible to healthcare professionals anytime and anywhere, enabling real-time monitoring and decision making. So this cloud computing is the platform which helps the healthcare professionals to continuously monitor the patient information from anywhere at any time. Now, benefits of IoT in medical devices. What benefits we have? First, it improves the patient outcomes and experiences. Providing continuous monitoring, early detection of health issues. Suppose I am using a IoT enabled sensors and the data is continuously monitored by the healthcare professional. It is a possibility of early detection of health issues. Suppose I am having my BP is around 100. Before going to 120, they can easily detect it, and you can take a personal care, which helps improve patient outcomes and enhance overall patient's experience. You will require very soon. Real-time data for better diagnosis. As I told you, the sensors will send data in a real time. So real-time data allows healthcare providers to make more accurate and timely diagnosis through a real-time, which can be used at cloud platforms. This is a very important point. Before going to this point, in US, because of introduction of IoT in healthcare, they have reduced their budget from 100, suppose example 100 crores, they reduced to 50 crores. They reduced 50%, incorporating IoT in the healthcare. How this is possible? As an example, a patient is there in the home, he is very panic. His heart rate is around 120. And after giving the traditional medicine, it become normal now. Now, after taking the medicine, if this IoT is not there, he has to come to the hospital. Even though he has a similar small problem, suppose he has a small problem, generally the patient will panic. He'll rush to the hospital, and the person who require real treatment may not have availability of bloods. So, in such cases, we'll use this cost reduction of IoT healthcare, where he no need to come to the hospital, and the medicine can be taken through the remote. Here, IoT help reduce healthcare cost by promoting preventive care, reducing the hospital readmissions. So after reaching home, suppose he got an issue, he'll contact the doctor directly through the, as doctor can continuously monitor his data remotely. He can suggest some things, some medicines, and optimize resource usage. So he no need to come to hospital again. Example I given all that I explained just now. A remote patient monitoring system can be eliminate unnecessary hospital visits, saving time, money for both patient and providers. Next, predictive healthcare and provision. So by using IoT, as we are using machine learning and AI techniques, algorithms, you can predict, is there any possibility for patient to get a disease in the future, in coming 2-3 years? That can be, and they can take preventions also. So IoT enable predictive analytics, which allows health providers to forecast health risks. They can forecast, or they can expect, or they can predict what kind of disease he may get in coming 2-3 years based on today's his health condition, and they may take preventive measures before condition become critical. So by analyzing real-time patient data, IoT can help predict issues like heart attacks, strokes, as the data is available with the healthcare professional. So you can analyze data after the patient moved to the home. So you can analyze again. So we can predict that he may have chance again getting a heart attack. Now, applications of IoT enabled medical devices. And RPM is a widely used application for healthcare remote patient monitoring. This is one of the very important application of IoT in medical devices, enabled device, or IoT in healthcare. It's one of the most significant application of IoT in healthcare. With RPM, what we can do? The patients can wear devices that track their vital signs like SpO2, heart rate, temperature, and other parameters such as heart rate, blood pressure, glucose levels without needing to visit the doctor. Yeah, this is one more application is smart wearables. Again, there's some gadgets are there. We can able to track the patient data. Then we'll see one more application. IoT enabled diagnostic devices. We can enable the IoT to collect health data and help doctors diagnose and monitor various medical conditions. Examples, we have some ECG devices. Today in hands-on, we'll see some ECG device where we can monitor the patient data to remote place. Emergency alerts, as I explained just now. Example, I taken a fault detection sensor is wearable device. Can it send an alert to caregivers or emergency responders, enabling the fast. Suppose a patient is there, it fell down immediately. Because of the sensor, which is there, wearable, it is if it fit with the patient, they will give alert to the caregivers or caretakers to respond immediately. They can respond in time and survive the patient. Then hospital assistant management with IoT. Hospitals can use IoT solutions to track medical equipment such as ventilators, wheelchairs. So for ventilators also, you can monitor remotely by using some RFID tags. Robotic surgery is, as of now, not suggested, but in other countries they are able to make surgeries to robot devices also. And where the doctor may remotely instruct the robotic device to how the operation should be performed. So even though it is not suggested as of now in India, it is going to is implemented in some other countries. The surgeon can remotely control the robotic instrument and access real-time patient during the surgeries. Let us come to the one more important topic called how we implement IoT in medical devices and what parameters you have to choose. So these are the 4 countries I have taken to implement IoT in medical devices. The first one is choosing the right industrial IoT service because we are going to monitor remotely, and development and IoT apps or dashboards. And IoT hardware integration. We have to integrate hardware and software. Then only it will work out properly to monitor remotely. And remote real-time monitoring, it can be app or dashboard. Let us see with the first one. Choosing a right industrial IoT service. In my example, I'm using Unidots, a IoT service, which can able to remotely monitor the patient data. So we should choose properly. To implement IoT in medical device effectively, healthcare organizations should partner with experienced IoT service providers that offer end-to-end solutions from hardware integration to data analytics and security. So we should choose right industrial IoT platform. So in generally in academics, we'll use either ThinkSpeak, ThinkSboard, or Unidots. The other are there, but professionally there are so many are there. In academics, we'll use regularly ThinkSpeak, ThinkSboard, Unidots. These are also right industrial services only, but they provide free services for limited accessibility only. Developing IoT apps for healthcare. So then in the session you'll get sir. Developing user-friendly apps that collect process. Generally, user interface should be the interface which is there for IoT applications should be user-friendly so that a layman can understand. Suppose I have an interface where I'll give my name, my heartbeat rate, and my some vital values. You should predict what can be the possibility of what diagnosis I can go for, or it may predict some diseases for me. So it should be very simple. So developing user-friendly apps that collect, process, and display real-time patient data is crucial. These apps should provide healthcare providers with actionable insights. So whatever the apps which are available, they should have access to the health providers. Make it easy for patients to monitor the health. Next one is real-time monitoring dashboards. Today, in today's session, we are going to use this real-time monitoring dashboard only using Unidots. So either you go for apps is mobile-based, and dashboards a PC or based will be a better view for the analyze the graphs or the ECG and other things. So real-time monitoring dashboards provides the healthcare providers with a comprehensive view of patient health. Comprehensive view means it's a better view of patient health can be lead to better decision making and improved patient care. Challenge is what we have as we are keeping data in the internet. The first problem we'll get is data privacy and security concerns. Not only with IoT, it is a problem with any. It is a problem with cyber security. It is a problem with cloud computing. It's a problem with any technology which is using internet. IoT device collect data, sensitive data of health data, making them to target to cyber attacks. Ensuring data privacy and security is essential for protecting the patient information. So we'll have some advanced algorithms which ensures that the data will go to the target person only. Integration with legacy systems. Now, integrating with IoT with existing healthcare systems can be challenging because we should do integrate software and hardware and seamlessly they integrate together to maximize the benefits of IoT. There is one more challenge which is facing by IoT. Then one more is high cost of implementation, as it requires more software, more hardware, integration, and more infrastructure. We require more cost. However, the long-term benefits, like even though we put large amount in a high cost while implementing, it will be done for a long time. It will get beneficial for the infrastructure, which is improved care and reduce cost. Initially, it may take some more investment to implement the things. After implementing, we'll have improved care and reduced cost. Of course, in first year they may charge more as it is getting better benefits and better results. They may reduce the cost. Technical challenges will be there in the IoT because there will be device malfunctioning. Suppose the device which is there I'm working on, it may not work proper because of shortage of voltage, or there will be software error will be there, or there will be connectivity issue also. Suppose I am using a Wi-Fi, it may not work properly. There is a possibility of that data may not go to the other end. So there are some challenges are there in technically also. A case studies in IoT medical devices. Let us take a few case studies. The first one is a remote monitoring solution for chronic diseases. So IoT device has been used to remote monitorly the patient data and allowing timely interventions and personal health care. This was the one of the case study. One more is wearable device for senior people care, where we'll able to monitor the data remotely. Same thing. I would enable diagnosis. Again, suppose there is no place, there is a place where the patient data will not go in rural places. They're able to enable this IoT diagnostics. So I would enable diagnostic devices such as portable ultrasound machines, ECG monitors, are helping healthcare providers in rural areas to offer accurate and timely diagnosis, where we connect these ECG or ultrasound monitors to the patient or a individual who is want to know the information is data to be known to the healthcare providers. These devices allow healthcare professionals to consult with specialized remotely improving patient outcomes in underserved regions. Let us take I'll give a break. Then we'll go to the technology used in IoT, then hands-on sessions. We'll go to one case study. I'll explain the code, then we'll go to the answer session. We'll go to what required for us. I'll give 5 minutes break, then I'll discuss what we require for hands-on. Then we'll go to the board. Let me start a hands-on session. Before that, let me have some theory session. Theory for 10 minutes about the background, what I'm going to do. So today we are going to monitor the ECG through IoT. Now, let us take a prototype example where a patient will be in here and the doctor has to monitor his ECG through a remote place. Before going to that, let us analyze how the ECG is. The ECG records a 10-second rhythm. On this, a strip, a heart activity is translated into line tracings. You can see a graph here where there will be just like a graph paper in our engineering colleges. We have a graph. Just like the similarly, we have a ECG paper which has a graph like symbol. We have large squares and small squares. The dips and spikes in the ECG or EKG cycle are called waves that represent different phases of heart activity. The 5 large, we can see here 1, 2, 3, 4, 5. There are 5 large squares which set to standard measurement depict 1 second. This complete 5 long square, big boxes of squares depict or represent a 1 second data, and one large square represents 0.2 seconds. So you can see here one large square. You can see 1, 2, 3, 4, 5. So 0.2 into 5 will get 1 second data. And small square is equal to 0.04 seconds. You can see here, there is small boxes here. There is small boxes. Each box will represent a 0.05 seconds data. So complete this graph is of 1 second. Each long box or a bigger box is of 0.2 second data, and each small box in the bigger box is 0.04 second data. So 0.04 seconds into 5 small boxes will 0.2 seconds. This is one larger box. 0.2 into 5 boxes will give 1 second data. So whatever I'm displaying on the screen is a 1 second data of a patient. And to read a ECG or EKG, it is important to understand the components of wave. We have P wave, QRS wave, T wave, U wave. We'll see, let us analyze what is P wave, what is QRS wave, what is T wave, and what is U wave. The P wave records electrical activity through a upper heart chambers. So as we know, our heart has lower chambers and upper chambers. The P wave will record the electrical activity through a upper heart chambers. You can see here, this red part indicates the P wave. It records upper heart chambers of arterial deposition and contraction. When it is the heart pumps and throws back, that will be recorded here through a P wave. Then PR interval. Then PR interval is from, you can see here, this complete only spike is P, and till it here it becomes a PR interval now. This PR interval spans from beginning of the arterial deposition, the P wave, to the beginning of QRS complex. Now from the P, before QR starts, there will be some interval that is called PR interval. This time for beginning the P wave to beginning to the QRS complex, it has what it can monitor health of the heart, and it may diagnose the diseases which a patient or individual can be predicted or analyzed using the ECG. The duration period of this interval can be determined health of the heart, and it helps to diagnose the patient data. QRS complex. This is a spike you can see here, from here to the large spike and comes down and goes back. It records electrical activity through a lower chart chambers. You can see the P wave will has recording the higher chambers, whereas QRS complex will record the lower chambers. It represents ventricular deposition or a contraction. It consists of Q wave. First, the downstroke you can see here. This part, the downstroke, is called Q wave, which is a downstroke. Then we have a R wave, which is a first upward deflection. Then S wave, the first downward deflection. This complete red signal as a QRS. Downward is Q, the upward spike is R, then the again downward spike is the S. This is called QRS complex. And T wave. The T wave is just like a P wave now. Like the P wave, the T wave records upper heart chamber activity. However, it represents arterial deposition and relaxation. Let us see how to read the ECG in 5 steps. So there are 5 steps. Step by step, let us analyze the ECG, how it, the P, let us first analyze the P wave first. Let us identify and verify the P wave first. The P wave located at the beginning of the ECG cycle should represent an and upright. You can see here the wave for normal human being. You can see there is a P wave that is absent and will be abnormal. So if suppose there is no spike here, you see there is a P wave here. I think I'm moving the cursor here. Are you able to see? Yeah. If there is no spike here, it means he has a abnormal health in the heart. The P wave should not be more than one large box. You can see here. If you go to the previous, I told there are 5 large boxes. The P wave should not exceed more than one large box tall and one large box wide. Normal duration of a typical P wave is 0.06 to 0.12 seconds only. You can see here one box is 0.04, 0.04, 0.04, 0.04. It will be 0.4 into 3 at 0.12 seconds. If you take this graph, it is a normal patient or normal individual graph. Is not this reading is normal, it is not abnormal reading. The abnormal, this spike may be more than one large box or there not be a spike at all. Measuring the PR interval. See here, similarly, the PR interval also. The next step is to measure the PR interval. To do this, count the number of small boxes in between the beginning of P wave and peak of the QRS complex. Because already we told PR interval is from the beginning of P wave to the starting of QRS complex. So we have to count the number of small boxes, not the larger boxes, small boxes, and then multiply with the number of by 0.04 seconds. If you see, it will be around 0.12 seconds to 0.120 seconds. The normal interval of PR for a normal human being, which is healthy, will have 0.12 seconds to 0.20 seconds on the graph. Then measure the QRS complex. The measure of QRS complex count the number of small boxes from the beginning of and end of QRS, means Q downwards, R spike, up spike, and S down spike. So beginning to the end of QRS complex. So you have to count the Q spike, R spike, and S spike. Then divide it by 0.4. The normal target range will be 0.06 to 0.12 seconds. So whatever the readings I'm showing is the normal readings, and the graph also duplicates the same thing. And now identify the rhythm. The 3 categories to find out the rhythm. So many are there. We'll see the first one, regular one, where we have constant R to R interval. So we have R wave where we have regular, means we will have constant R to R interval, and regular irregular also, where we have variable R to R interval with a pattern. We have pattern of wave. We have spikes of waveform. Then we have irregular also, variable R to R without no pattern. We may not get many spikes. If the distance are constant, then the rhythm is regular. If not, the rhythm is irregular. Suppose in the graph, if I found the distance are consistent in the graph, we'll see even the example graph. If they are regular in the rhythm, we'll say it is a normal, and it is irregular. It is irregular if the rhythm is not there properly. There are so many methods to analyze the patient data of ECG. The normal BP per minute, beats per minute is 60 to 100 beats per minute. Depending on the rhythm, we'll have some various methods. We will see one method is the big box method, where if the heart rhythm is regular, you can see a big box method. To do this, divide the 300 by number of large boxes in the between the R waves. So if for example, there are 5 large boxes in between S to R, set of R's, the heart rate would be 60 BPM, beats per minute. 60 beats per minute, because I divide by 300 by 5, I'll get 60. Similarly, 6-second method is there, where if the heart rhythm is irregular and you are working with 6-second strip, the 6-second method is an easy and viable option. Generally, we'll use big box method for a regular or normal patient who is a working or active in the activities. But this is used for a irregular patient or abnormal conditions. First start by counting the R waves from beginning to the end of the 6-second strip. Once you find the counting, multiply that with the number of 10. Suppose I have 6 R's, then it is 6 into 10. You'll get 60 beats per minute. Now coming to this one, today's we are going to interface AD232 ECG monitor with the ESP32. So before I start about explaining these things, let us show with hands also what is AD322 device sensor. Let us take a 2 minutes break to interface the device, interface the board to analyze the things. So we're using AD8232 ECG sensor. Yeah, sir, can you zoom it? Yeah, this is a sensor. This is a sensor which reads the ECG. It has 7 pins. The first pin is ground pin. The first pin is the ground pin. Then we have a supply pin 3.3 volts. Even this board, as suppose E32 has providing the 3.3 volts to the AD8322 sensor. Then we have output pin of the sensor given to the board. The output pin of the sensor is given to the board. Then we have a lid off and lid off plus and minus. And to measure the ECG, we require a right arm, left arm, and right leg. So we'll connect these 3 wires to the patient or individual in right side of the heart, left side of the heart, and right leg. That is a traditional method to connect. But today we are connecting to the patient through his hand only. Let us connect the. So this is the ECG. There are 3 wires of ear. Yeah. Now I connected a. I'll take on my friend's help. I'll make the connect the devices to the him. Yeah. I connected the right hand, left, right arm, left arm, and right leg to demonstrate to a single hand. Now we'll try to run the code and publish this data remotely to the cloud. Yeah, let me run the code. This is the board we are using. Yeah. Yeah. Now I'll switch to the Arduino IDE to dump the code. I'll explain the code afterwards. Let me run the simulation. Let me run the code once and deploy the model first. Now after dumping the code and uploading the data, we publish data from the patient to the remote place. Now, after uploading, we need to take the UD credentials. It will take some time to download the code. Right, taking some code is a little bit lengthy. It's taking some time. Yeah, it's writing now. When zoom it to the sensor, it shows the heart shape. There is a LED blinking, so it's working properly now. Yeah. Now the data is sent to the remote place. One of my uh, audience will share the screen now, where you can be able to monitor the remote data of a patient. Yeah, we'll make her as a host. She'll able to share the data now. And the procedure I'll tell you, the one of the participant can involve here. We'll share the procedure how to create a UDB account, and he has to share his token so that he can able to monitor the patient data from his place also. Yeah, I'll stop sharing now. Let us share the screen. We're making our previous session speaker to observe data remotely. We made as a host now. Now, if you share the screen, it is easy. We are able to see the ECG of this patient, the remote place now. Zoom it. Or you can see, come down. Please, ma'am, can we come down? You can see the data manually also. The numeric data also will be there. Please come down. By changing the positions, as we kept to the hand, it is not showing exact spikes. If you give it to the body, it will get proper spikes. We'll try once. I'll have to keep near to the, sorry, keep it here. Red one should go near to the yellow one, middle. As you can see the numeric data also here. Now we can generate a CSV file which can be further analyzed for, or data analysis can be done for this a patient. You can see we are getting a data numerically also, and we can import this data. There are various formats. Yeah, you can see there export data. Yeah, I'm inserting her for the remote only now. I'm through internet. I'm inserting her. Yeah, you can click on OK. You will get a CSV file. You can download it and further analyze using machine learning algorithms to predict the future diseases. Yeah, let me share my screen how the actual data looks. As if we come to the hand, it is showing a little bit better. Unless we can see through the graph or PPT. Yeah, yeah. Here our motto is to remotely monitor the patient data. As we come to the hand, it is not showing exact readings. If we go to the proper positions of the body, you'll get a proper readings. To perform this experiment, we require. Yeah, let me share the screen. How to perform this experiment? To perform this experiment or a case study, we require ESP32 board which is there here. This is a custom made board for our college, which was a board. Yeah. This on motherboard we have S32 module, then we have OLED, then there is a 3 volts and 5 volt supply facility is there. Then we have a relay and drivers, then we have stepper motor, and so many components are there. Now from this we are using only a relay and we are using only IO pins. It's a custom designed board which can be used for IoT applications. Let me come to again my PPT. Yeah. So we require ESP2 board and AD82 ECG sensor and a micro USB cable to download the code into the. You can for micro USB cable is required to download the code from board to the from PC to the board, and we require some connecting wires. The minimum wires required is 7. Coming to the medical use of ECG, as I explained already, it is able to detect the clogging of heart blood supply and heart attack in the past. If it is there, it will be seen in the wave and enlargement of one side of heart and abnormal heart rhythms. Heart rhythms. Now this is a sensor which I explained just now. You can see here AD82 sensor, the cost-effective board, and this is the module. These are the pins we used in our interface. SDN is not used. Shutdown pin is there. We will not use for our experiment. We'll use LO plus, LED off, LED off, LO minus, output and 3.3 volts. The output is taken from the patient and given to the ES32. And we are connecting 3 wires like right arm, left arm, and right leg. So as we not connected as per the given pattern or recommended pattern, so we are getting but normal values. But I will get the output in this way. You can see here this is the pattern you have to connect as actually. You can see here a left leg, a right leg, and left hand, right hand, and a right leg. So as and in this way, for me it got a proper wave. You can see here. It was done 1 week back. Yeah, this is about the hands-on session about ECG monitoring through IoT from remote place. Now I'll come to conclusion. The integration of IoT in medical device has a potential to revolutionize healthcare by enabling real-time monitoring and reducing the cost also, because we are monitoring the patient remotely as he now need to regularly visit the hospital, and improves the patient outcome. Despite of challenges we have, even though we have challenges as security concerns and high implementation cost, the benefits of IoT overweigh the obstacles. As technology continues to advance, the future healthcare looks more connected, efficient, and patient-centric than ever before. Yeah, thank you. You can raise the questions now. Yeah. Any queries, you can reach me, dshod@kmed.in.
Thank you, Anil sir, for such an informative session. Thank you all. Good night.
As it is time is 9 p.m. now. Anybody want to verify this session? We can have one more session, one session in the coming classes. They can create a UBA account. We'll share the procedure. You can create an account. We're making our previous session speaker to observe data remotely.